OK， 这个我们这里啊，我们这边就刚才前面我们讲的是一些 simple data structure. Based on the simple data structure, we can construct more complicated data structure for GIS. The whole polygon structure is the earliest version of GIS data structure. So it's quite simple to implement it because everything is a polygon. So for example, if we want to digitize this shape, then we just 1, 2, 3, 4 and enclose it. So it becomes a polygon, one polygon, second polygon, third one, and the fourth one. And the 4 polygons become to complete the whole pictures. But this method have some disadvantage. Although the advantage is very simple, it's quite easy to implement, and you can use a very simple formula to compute the area， 就算面积啊，你这个只要一点完，这个一点完，面积就出来了，所以它可以算面积，而且程式很好写。But there are some problems. So it's a common point or common edge. That means it will have this kind of problem because 1, 2, 3, 4 is this polygon and another one this one. So they have actually the point 2 and 8 actually is the same point, but because you digitize twice, it is impossible for you to digitize at the exact same point. Right? So you may have very strange edges. Actually, it should be a 1 edge, but you got 2 edges. Even worse, the middle point has 1 point, and there are actually 4 times of digitization, and you got 4 points in the computer. So the area of these 4 sub polygons, the total of the area is not equal to the whole area. But because it's very easy to implement, so in the early days, the cadastral map digitization is used this way. 就是早期的地基图，台湾早期地基图就是用这样的方法。那时候都没有 GIS at that time. Well, about 20 or 30 years ago, at that time there was no GIS software. So the programmers in the Bureau of the Land Management, they wrote program by themselves using Fortran. So it's very easy to implement. But they must digitize very careful, very careful. 所以这个早期你就是说看那个地基图数化都是用这个方法，你自己去写程式。So to overcome this, so you have the first problem is you encounter the problem of common edge and common point, and you cannot to know the adjacent polygon. So that means if I ask, okay, if we call this a polygon A, B, C, and D, if I ask a question, say, okay, which polygons adjacent to polygon A? Actually, there's no way to answer this problem in this structure because you have no idea, because you cannot decide by this line because there are 2 lines, not 1 line. So you cannot answer this kind of query in this data structure, in the whole polygon structure. Okay? And the subpolygons, the total of subpolygons is not equal to the total area. 所以早期的地政师它地基图重画，农行所如果做非都市土地利用图的书就是用这个方法。That's in the early day, I'm telling you, because at that time there was no GIS software, so the only way you can do is write your program by yourself in the most simple way. 所以。So the next version is arc node structure. Okay, arc node structure. Arc node structure is in the let me see in the电脑在做做什么事情？好吧，是我电脑的问题。Okay. In the figure B, 对这个 B 来讲okay. However, in the whole polygon structure has a advantage to calculate the area in between two polygons, because if you digitize in clockwise order and digitize the inner polygon in counterclockwise, then and add them together, you got the area of this portion in between. Because when you calculate the area in clockwise order, you got the positive area, and you got a negative area if you do it counterclockwise. 好，就是说你如果顺着时钟这样竖画的话，你得到的面积是正的面积；逆时钟的话，你得到的面积是一个负的面积。你两个把它加起来，刚好是中间的那个面积。Okay, to overcome the deficiency of whole polygon data structure, you can do it. Okay, here just like 1, 2, 3, 4, 5, 6, 7, 8, 9, and in the vertical way 1, 4, 7, 4, 2, 5, 8, 3, 6, 9. Then every point could, well, okay, each edge only digitized once. And here could be the point that can be digitized twice. Okay, but here, well, you don't have to digitize it. You can make a algorithm to find the intersection. Okay, so you can reduce the problem in figure C a lot. And you can write a program, say, okay, I know the point 1 actually is the same one, because if you allow some error tolerance. Okay, so the computer can decide the point. Okay, they can combine this to digitize the point into one. Okay, so 所以这个第二个呢 is arc node structure. We call it arc node structure. Arc node structure. At that time, the graphic database and the attribute database are separate, constructed separately. So you have to construct the graphic database and the attribute database into a different software. Okay, and these two have the different data structures. In the arc node structure, the point, line, and the polygon are stored in different layers. And every node, link, and polygon has a unique identifier. So I already mentioned it. There is a system ID and the user ID. System ID are given by the system automatically for their internal computation. But for the user, you can define your own ID sequence. For example, you can have a road name or address number or building numbers, construction identifiers. And some dedicate GIS. That means, well, the GIS software is designed for some particular application. It's not a general application. ArcGIS is a general one, general purpose. But some GIS software is dedicated for some particular application. So in a particular or dedicated GIS can be digitization and to construct a topology at the same time. So when you digitize it and the system construct its topology simultaneously, they can do it. But for the general purpose GIS, well, generally they have to digitize the map, then to analyze their topology after the digitization, okay, in two phases. At this time, arc node structure, there is no difference between geometric attribute and the thematic attribute. That's a very big table to indicate the attribute. But in the third one, next to the arc node data structure, we got a relational database. At this time, just like the arc node structure, the graphic database and the attribute database are constructed separately. But the attribute database will become a relational database. We use the relational database structure because at this time, the relational database management system was developed, okay, at that time. So before that, there's just a big table. You must construct a big table. But in this stage 3, well, we can use the relational database just like Oracle or some Access, or we have Informat. So in this moment, we can distinguish geometric attribute and the thematic attribute. The geometric attributes is constructed after you constructing the topological relations. So in ArcGIS, we have some clean or build up. We have two commands, say clean or build the structure. That means you ask ArcGIS to establish the topology for you. Okay, and at that time, the the ArcGIS will